All right, thank you for joining us today. And in this video, we are going to go through this example together, right? So this question is asking us to find the derivative of the following functions, right? And this one, we are going to use what is called the power rule, right? So what is the power rule? The power rule says that if I have, let's say, f of x, which is equal to, let me say, x to the power n. Then if I want to differentiate this, I'm going to have f prime of x, which is equal to n drops down times, then I'll write down the function, but I'm going to subtract 1. So that is the power rule, right? So that is what you are going to do here. So looking at our first function here, this is what you are going to do. Since we have f of x to be equal to this, then using the power rule, our f prime of x is going to be, now there is a constant here multiplying the function, so we are not interested in it. So one thing about differentiation is, if we have a constant multiplying the function or dividing the function, you can what? Bring it out, except when the constant is adding or subtracting. That one is different case. I'll get to the last one and you understand. So whenever you have a constant multiplying a function, or let me assume that this one was x squared divided by 5, we can factor it out. Then we will focus on the x function that you want to differentiate. So this is going to give us 5. Then now I want to differentiate x squared. So using the power rule, what am I going to get? This is going to give us 2 down. Then I'll write my x squared, then I'll subtract 1. So when I simplify, I'm going to have 2x, right? So if we want to compare to this one, then if I have this one, then my n is what? 2. So it's like just doing substitution. I'll put 2 here, I'll put 2 here, which is going to be like this. And then I'm going to have this. So this is going to give us 2x minus, I have 3 here. Now, when I differentiate x, what am I going to get? So this is to the power 1, right? So if I want to use the power rule, this is n is equal to 1. So I'll put 1 here, I'll put 1 here. That's the idea. So I'm going to have 1 times x, 1 minus 1, 1 minus x to the power 0. Sorry, this one should be times. And then x to the power 0 is 1. So I'm going to have 1. So one thing that you need to know is, when I want to differentiate x with respect to x, I get 1. Very simple. Plus, when I differentiate a constant, I'm going to get 0. So you see that here we are getting this one to be 0. Why? Because there is no function multiplying or dividing, right? 2 is standing alone by the idea of using what? Addition, right? Is standing alone. So when you see any number which does not depend on the value that you are differentiating with respect to, that function should give you what? 0, right? So if this one is minus 2, you are going to get 0. But when you see that there is a constant multiplying the function, then you can just factor it out and then differentiate the function that you are interested in. So let's simplify, and then we are going to have 10x minus 3. So this is the power rule. Very nice. Now let's look at the b. The b here, I'm going to do something, I want to make my life very simple so that, I'll be able to differentiate using the power rule. So first, I'm going to simplify the function. So this is the same as 6. Now, what is root of x? Root of x is the same as x to the power 1 over 2, right? So this is going to give us 1 over 2. Nice. Then look at this function here. I have 7 divided by x. This is the same as 7 times 1 over x, right? And I can write this one as 7 times x to the power minus 1. So I want to make sure that they are in the form of, power, so that I can use the power rule to differentiate. So I can write this one as plus 7 times x to the power minus 1. I have my constant, so 5.6 there. So that's what I can do. Now I can use the power rule to differentiate. So now let's find for G prime. Now power rule, when you are using the power rule, now as I said, 6 is multiplying it, so I just bring it in. Then now I want to differentiate this. So this is going to give me 1 over 2 drops down, right? Then I will write my x to the power 1 over 2 again. So 1 over 2 drops down. Then I'll write my x to the power 1 over 2, but I'm going to subtract 1. So that's what I'm going to get. Plus 7. Then I'll differentiate this. So minus 1 will drop down, which will be minus 1 times. Then I'll write this one again, my function again, x to the power minus 1, but I'll subtract 1. Plus, when I differentiate a constant, I get 0, so plus 0. So let's simplify. This one will be 6. This one will be 1 over 2. Now, I want to look for 1 divided by 2 minus 1. But this is the same as over 1, right? So this is a very simple way of me doing my fractions, right? So this is the same as, this is how I'm going to do is, I'll use this one to multiply this. So I'll have 1. Then minus, I'll use this one to multiply this, right? Then I'll have 2. Then I'll divide it by this times this, which is going to give me 2. This is how I do my fraction, and you can test it with any fraction. It's going to work for you. Any fraction. Multiply this by this is here. Multiply this by this is also here. Then when you finish, you multiply the denominator together and get what is here. So now this is going to give us negative 1 over 2. So we are going to have x to the power negative 1 over 2 plus. So I can multiply 7 to the negative 1, which will be negative 7, then minus 2. So this is what I'm going to get. If I want to simplify, then this one is going to be 3 times. So the half and then 6 is going to give us 3. But this one can be written as, because the minus is here, I can write this one as 1 divided by x to the power 1 over 2, then minus 7 times. This one too can be written as 1 over x squared. And then I can write this one as 3 divided by root x plus 7 over x squared. Very nice and very simple. But I think this one's supposed to be minus. So this is what you are going to get for your derivative when we differentiate the function. Right. So that is very simple with the power rule. So I'll give you similar example, like similar one, then you try and then you put your final results in the comment section. So now let's look at this question here. You are going to use the power rule to differentiate this and also differentiate this. So in the comment section, you can type A, then you put your results there, B, then you put your results there. See you in the next video.